Hello everybody. First of all, I would like to thank BML team for giving me this opportunity to share my research. I present myself. I'm Mohammed Jamii, PhD student at Mohammed School of Engineers. So today I'm gonna present my work concerning using the Box-Jenkins ARIMA approach for long-term forecasting of dioxide carbon in Morocco. Let's get started. In my presentation today I will be discussing introduction at the beginning, aim of my work, problem formulation, then obtained result, and in the end, conclusion. As well, global warming is one of the most gripping and complicated problems facing the world. It's generally caused by greenhouse, mainly CO2 emission into atmosphere. As we know, dioxide carbon emission around the world continue to increase. The solution is proposed predictions dioxide carbon emission in Morocco by fitted model ARIMA. And prediction dioxide carbon emission is an important element to create awareness among public on how to solve environmental problems. The aim of my work is propose a model to predict carbon dioxide emissions by building an econometric model for forecasting carbon dioxide in Morocco during the period 1928-2020. And forecasts of dioxide carbon emission on our territory will help the country's political leaders to negotiate a climate fund with the international community. Forecasts of CO2 emission can be used by researchers, stakeholders, and the Moroccan government to take adequate measures to implement a sustainable climate policy. ARIMA model in our research is divided by two submodels, AR model and MR model. AR model is responsible for predict future behavior based on past behavior. For MR model is also known as moving average process. Is common approach for modeling invariant time series. The moving average model specifies that the output variable depend linearly on the current and various past value of stochastic term. The procedure of model is structured as follows. We start by collection our data and examination, determine stationary of time series, model identification and estimation, and diagnostic checking, and in the end, forecasting and forecast evaluation. So we started by collecting our data. We note that our series is not stationary as shown by an upward trend over the period 1928-2020. This simply shows that the mean and variance of annual dioxide carbon emission change over time. So, in addition, carbon dioxide emission dropped by 7% in 2020, the biggest decrease in record as countries worldwide imposed lockdown and restriction on movement to curb the spread of the coronavirus pandemic. Indeed, after applying the unit root test on our series, we found that the ADF value of the first difference is minus 8.91, which is below the critical value of the significance level of 10%, 5%, and 1%. Respectively, it is stationary at the first difference. The next step is to simulate the procedure of the dioxide carbon emission series. We start by using the kilogram of the stationary series, and from the autocorrelation coefficient and partial autocorrelation coefficient, we try to fit a random time series. And in our result, in order to obtain the best ARIMA model, selection criteria such as log likelihood, AEC, a key information criterion, and BEC, Bayesian information criterion, and RHQC, Hannan-Quinn information criterion are used in this research. And the ARIMA 2111 model is chosen as the optimal model due to the lowest value of IEC, BEC, and HQC, and the maximum value of log likelihood as it can be seen in this table. We notice from the table that Jack Bera equal 454 indicate a critical probability of 0.52. So we accept H0 of normally of residual. Therefore, homoscedasticity residues are verified, and the residues are white noise process. So the parameters of ARIMA 211 are listed in this table, and thus the forecast model can be written as follows. For our simulation result for forecasting in dioxide carbon emission is clear. A comparison between the actual data obtained from data set and the predicted data based on the ARIMA model, it can be seen that the two graphs match well. The predicted data follow the shape of the shape graph. They show the extent of convergence of the model estimated from the realistic data. For the result in this figure in the right in the slide show that by 2040 the annual exit emission would continue to grow and between 69 megaton and 109 megaton. The main explanation for this increase may be about power generation and transport are the main sources of energy-related CO2 emission in Morocco. In the presentation, in the end, we have examined the forecasting of CO2 emission in Morocco based on the Box-Jenkins approach ARIMA, and the results show that the ARIMA method performs well in forecasting CO2 emission for the next 20 years and show an increase in dioxide carbon emission. These results are important to the Moroccan government, and this knowledge can be used in the decision-making process such as energy control in the transport sector, and some recommendations can be listed as follows. Support the integration of renewable energy sources in homes for household self-consumption, and the Moroccan government ought to reduce pollution by implementing policy actions such as increasing tax on the polluting companies, especially those that use fossil fuels in their daily production activities. And adoption of electric cars is also highly recommended as it will decrease the transport sector's emissions, especially if the energy needed to run them is produced by renewable sources. And in this regard, there ought to be well-organized awareness programs to be administered by the Moroccan government and other relevant partners. And thanks for your attention.